Yes, now I can see it. Thank you.
Okay. Sorry about that, ladies and gentlemen. A little technical
Okay.
difficulty, but we have the article that the doctor wrote, and it's
Yes.
titled Large Blue Object Close to the Sun and Stellar Cores, a Physicist's Thoughts. And this is dated for today, June 30th,
Yeah.
2017. And doctor, the stage is yours.
Okay, thank you, Scott. So we start with the images that you first took on May the 10th, which showed a large blue object close to the sun. And the object didn't seem to be emitting light. It looked blue. It seemed to have blue, pale yellow stripes. So blue with pale yellow stripes. And by doing a size comparison, I thought, well, the object seems to be close to the sun. We now know actually that it was so close that it was in the sun's corona. So it's possibly just a little bit behind the sun, which means that it is being illuminated by the sun. So this is why we would see it doesn't seem to be emitting light, but rather reflecting sunlight. So it would be close to the sun, a little bit behind. So a size comparison with the sun would reveal that it is about 1/3 of the size of the sun. Now, an object that is 1/3 the size of the sun is 3.3 times the size of Jupiter, because the sun is 10 times larger than Jupiter. So immediately we have an extremely large object close to the sun. And the objects seem to have stripes. And what kind of objects in the universe have stripes? It's gas giant planets like Jupiter have stripes, and brown dwarfs, which are substellar objects somewhat between stars and gas giant planets, and with the same type of cloud formations as gas giant planets, so striped cloud formations. So initially this object looked like it might be a gas giant or a substellar object, a brown dwarf. However, you then made some other observations of this object, and I think the first ones were on May 10th, and then 2 days later on May 12th you made some more observations, and these were clearer. We could actually see the surface of the object. So if we move down a little bit,
Okay.
we will be able to see.
You want me to go to figure 2 or further?
Further down. All right, here we can stop and look at an artist's impression of a brown dwarf. And this brown dwarf is 7.2 light years away. It's supposed to be one of the oldest brown dwarfs. But as you can see, it's gaseous. It has a gaseous atmosphere. And this one is blue, and you can see the cloud formations are striped in nature. So this is a brown dwarf, and this is one of the reasons why we thought this object might be a brown dwarf. Although so close to the sun, it's difficult for a brown dwarf, even a brown dwarf, to survive, because its gaseous atmosphere would get so hot that it would turn into plasma and again be absorbed by the sun. But at the time, we were not actually sure how close the object was. The next images that you took through your telescope, however, revealed a lot about this object. So if we move down to figure 4, we see actually the surface of the object in those images that you took. And as you can see, there were grooves. Now, only a solid object can have grooves. If this object had a liquid surface, liquid flows, and therefore it would fill up the space between the grooves. And the same thing would happen if it was a gas. A gas fills up any space. So there wouldn't be grooves if this object had a gaseous atmosphere. So the fact that it has grooves shows us that it has a solid surface. Now, if it has a solid surface, and don't forget that objects usually become denser the deeper down you go into the interior. For example, the Earth gets denser as we move down towards the core. The whole density of planet Earth is about 5.5 grams per centimeter cubed. The core has a density of 13 grams per centimeter cubed. And even the outer core, which is in the liquid phase because of the heat, it's still more dense than the surface of the planet. or even the mantle. So all objects increase in density as you go down towards the interior. So this means that we would expect if this object is solid on the surface, it will be even denser in the interior. And what else do we see? We actually see that the stripes that we saw on the object are not actually cloud formation stripes. It actually looks like it's made up of some solid material that is clinging to the surface, but it's much less dense than the blue surface of the object. It looks to be maybe spongy or clumpy or made up of different materials because we see different colors. We see light yellow, we see dark yellow, we see some gray, we see some brighter yellow. We see it seems to be a whole mixture of materials that is still clinging to the object. And in the left image, you even see it looks like there's a gaseous type of material seemingly coming off the object. And it looks like clouds coming off this object of material. So that's interesting in itself. And as we go and move into the next images, I'll talk some more about what I think this gaseous material or clouds.
I wanted to go ahead and just say one thing and ask you,
Yes.
and we've spoke about this before.
Mm-hmm.
Ladies and gentlemen, I don't know if any of you have noticed, but over the years, and even more now, the NASA artists' conception or rendition of what these objects look like. You always see it in these space agencies, videos, photographs, things of that nature. And whenever they discover something and publish an article about a brown dwarf that they found 55 light years away or 20 light years away, at the very bottom of that photograph, it's an artist's conception of this object. And these are NASA artists. So they're pretty damn close. So it makes me wonder where these NASA artists are getting their conception, because you're just not going to dream this up. What do you think about that, Doctor? Because they're pretty spot on.
Yes, well, I would think that NASA and whoever is studying these objects has been studying them for many years. They've been observing these objects as they come into the solar system, as they get to the sun, and what they do to the sun. Also, they need to know exactly where these objects are in order to program their planes to put in their to chemtrail in the right places so that people don't see them. As you know, they don't chemtrail every day, and they don't chemtrail all over the sky. They not every day. Sometimes they do, but I think that it is programmed to if these objects are visible over a certain part of the surface of the earth where there is a large population, then certainly if the objects are over that area or they would be visible, then they would chemtrail then. So they definitely need to know exactly where these objects are in order to hide them properly. They also need to study them to see what they are doing to the sun and when they might have to remove data from, say, to do with the SDO, when they need to hide more of it. So we don't see it. Of course, some of it always gets out. That's why we have been able to get the understanding that we now have.
Well, I definitely agree. They do remove data. On my earthquake report today, on the sudden and rare earthquake in Cuba and over in Uganda on the African continent, two rare places where earthquakes occur, and just makes you wonder. So as I was doing that video, I was showing some data from the magnetosphere, and there was 4 hours of data missing on the solar wind and the magnetosphere from 4:30 a.m. till 8:30 a.m. UTC time today.
Yes.
Today, folks.
Mm.
And they clearly deleted the information. They do it all the time, and sometimes it scares me that they just went ahead and put some animation in there to make us believe that nothing's going on.
Mm.
And people say, well, why do you criticize NASA so much and then use their tools? Well, listen, that's all we have. That's all we have. And sometimes, most of the time, we do have to rely on it. So that's that. But go ahead, Doc. You get back to your report
Yes,
there.
thank you, Scott. Well, you mentioned an earthquake in Uganda, and don't forget, Africa is the most stable continent. We hardly ever see earthquakes in Africa. So whenever there's an earthquake in Africa, we think something's going on. And the fact that they've removed some of the data to do with the magnetosphere, because this would be the first place that I would look for what is actually happening that is causing so many earthquakes. So that in itself tells me that something was happening. And I believe when it came back on after they removed the 4 hours, there was a high density around the bow shock. So there may have been even higher density. Also, I saw that the whole face of the sun seems to be turning into a coronal hole. So we would expect very fast solar wind and very energetic particles coming from the sun. And therefore, we would expect this kind of thing to happen.
Yeah, whenever I was reviewing that data this morning, and I saw that very quickly because I could see the jump in the model animation, and I'm like, okay, that doesn't look right. So I immediately always go back and start looking at the timestamp, and that was very easy to find. They were very blatant about that.
Yes.
And today, like I said, BP Earthwatch, he did a really good video on them hiding information with those little square pixel boxes that they use. I mean, they're always using the same excuse. It's a glitch in the camera. It's this. It's that. What's the saying for NASA? Never a straight answer.
Yeah.
But anyways, getting back to your report here,
Yes.
because it's definitely very interesting.
Yes, thank you, Scott. Okay, so the next image again is an image that you took. I think you enhanced it with some extra color. But what we can clearly see is that this object is shedding that yellowish material on its surface. You can see that we can still see some of it looks like stripes across the object. On the bottom, we see an area where the deep blue surface is clearly visible, and we see that some of the stripes are missing from that area. So that's a sign that the object is shedding this surface material. Also, it's thicker in some areas than others. It even looks greenish in this color. Also, on the top left hand side, we see almost like there's a connection, a plasma connection between it and the sun. So it's not as clear as in the current images, but there is a hint that that is happening. And so as you can see, it's quite obvious. This object has a solid surface. It has material clinging to its surface. Some of the material is in the shape of stripes, and it's obviously losing it. There's also a lot of small objects around this larger object. So perhaps debris, perhaps other smaller objects that may be stellar cores. The recent information that I have seen is of the sun's corona having significant numbers of very small objects that would be at home as well in the sun's corona, almost at the sun's surface. And these would, of course, be stellar cores as well, or stellar remnants.
Yeah, there's no doubt. We've been uncovering those, and
Yes.
I really don't think they do. The boys in blue there. I don't think they do that in depth of viewing. I think they have to do this quick. They have a lot of data to go over, and I mean, I truly believe they miss a lot of things a lot of times, and that definitely goes into our favor. They're probably listening to us now, but well, that's too bad, guys. We're still going to be here. We're still going to be watching. We're still going to be plugging away.
Yes.
But I blew this photograph up for everybody, and the reason why I wanted to, let everybody see this, all of these white dots that you see on your screen. It kind of looked like flowing debris on the backside of this object. And doctor, I know I've asked you this question before, and I know the answer, but for all of our viewers out there, what do you think this all of this debris that we see, these big debris fields, we see them all the time on the LASCO coronagraph imaging. We see them on the SETI and the stereo, and it's just all of a sudden it's just constant, constant, constant. This big influx of all of this debris. Do you think this may be one of the root causes?
Yes, I think so. Don't forget, we cannot forget how this kind of object would form. First of all, they would start out, this is a core basically of what was once a main sequence star. So this type of object forms in the center of a star. And it does so because as the star fuses material, the more dense material would sink down into the interior of the star and accumulate at the center of the star. It becomes the core of the star. It's extremely dense. The sun's core is the accepted value of its density is 150 grams per centimeter cubed. So that's an extremely high density. So this type of object would be the core of a main sequence star. But there comes a time when main sequence stars, well, the accepted theory is that they run out of material to fuse. I no longer believe that. I believe now that stars are electrical objects, and it's therefore all about the energy. So I think there comes a time when a star runs low on energy. It's no longer able to ionize its at least the top layers of gas. And when that happens, it starts growing in size and it becomes what's called a red giant. A red giant therefore starts ejecting its layers of gas. And that progresses between the red giant phase and the white dwarf phase to the point that it's no longer able to ionize it to such an extent that it loses it in large amounts. And that to me always suggested that these objects ionize their surface. That's how they produce their light, well, some of their light. They are then able to have fusion reactions, not in the center. They cannot have it in the center. Stars have to be dark in the center because our sun actually goes dark at times. So they must be having fusion reactions on the surface, but stars are not that hot on the surface. Our sun is only 5,800 degrees Kelvin on the surface. So what that shows is that the fusion reactions that are happening are cold fusion that happen at lower temperatures and are powered by electrical potential energy that the star has. So at the time that the red giant turns into a white dwarf, this stops happening. It's no longer able to have fusion reactions because its electric potential energy has dropped. But initially, the white dwarf is hot, but it has released such a huge amount of the layers of gas that were once part of the main sequence star, that the white dwarf is basically the core of what's left of the star. And the thin envelope, which glows, well, it glows from the surface still, and the envelope itself of the star, which is made out of a thin layer, but ring-shaped, so that the object may even look like a disk with this, it looks gaseous envelope. It's actually plasma because the object is still able to ionize it to a certain extent. And this is what you end up with, is the core and the large, and then the envelope, and beyond the envelope there's a large cloud, and it's diffuse which is made out of the material that used to be the layers, the outer layers of gas that made up the star. And the
I'm sorry. You know what I wanted to touch on real quick?
yes.
Just sorry to interrupt you, but some people had some questions earlier on, and I
Hmm.
just wanted to touch on those questions because it was just, just I was reminding myself here of the magnetic fields of these types of objects. Even if they are very, very small,
Yes.
their magnetic fields are huge.
Yes.
And would that type of magnetic field disrupt our planet? Like, for instance, all of the crazy weather that we're having, the wobbling of our Earth.
Yes.
If our Earth was wobbling
Yeah.
more than it usually does,
Hmm.
interrupting the jet streams around the world, and also all of this cosmic and solar, all these cosmic and solar particles in our ionosphere,
Yeah.
do you think that that is one of the root causes for all of this crazy and wacky, intense weather?
Well, it's definitely a strong possibility. Now, the reason why these objects have such high magnetic fields is because they shed so much matter, they get so much smaller because they basically now just a core and a thin layer of gas, that they start spinning very fast. And that's according to a conservation law that we have, which is conservation of angular momentum. When a rotating object decreases in size, it rotates faster in order to conserve angular momentum. And, and a charged object with currents on the surface that rotates faster, what it leads to is an incredible increase in magnetic field. So this is why white dwarfs have extremely high magnetic fields. But white dwarfs are, after a while, they will cool down and become basically what I have up to now called brown dwarf stars, but now I've been calling them stellar cores or stellar remnants because that's what they are. It's what's left of a star. And they will also have very high magnetic fields because they're also a lot smaller than the initial main sequence star that made that this object was a part of,
So
was the center of.
we're talking about hundreds and hundreds of millions of miles that
Yes,
the outreach of their magnetic fields can affect other planets.
that's right. So these objects have magnetic fields that are 100 times, 1,000 times, maybe 10,000 times greater than the magnetic field they had as a main sequence star. And that has been part of the research into white dwarf stars. But even one of these objects with a magnetic field that's 100 times or even 10 times larger than the sun's magnetic field would, of course, have quite an impact on the sun. The sun itself produces a magnetic field. It has a surface magnetic field. A lot of the effects we see on the sun, including plasma loops, are all magnetic in nature because charged particles spiral along magnetic field lines. So when these objects connect to the sun, basically the sun's magnetic field is pulled outwards towards the object and it closes inside the object. Magnetic field lines, of course, have to form closed loops. So it means that as the sun's magnetic field lines, and we know they are perpendicular to the surface of the sun at coronal holes, they would go out towards this object and come back towards the sun. And then the sun's particles would spiral along these magnetic field lines and therefore move outwards from the surface of the sun towards the object. And therefore you would get a particle flux transfer between the object and the sun. Basically, this is what we're seeing in this image. But going back to what's happening to the Earth produces a magnetic field. The Earth has magnetic poles. When we have an object that has a high magnetic field coming towards or being close enough to the Earth, of course it would disrupt its magnetic field, because it would, and of course it's a rotating object, which leads to a changing magnetic field. A changing magnetic field will induce another magnetic field in the Earth itself. So it would disrupt the Earth's magnetic field, and it would lead to the poles, the magnetic poles the Earth has to shift. And I have seen that it seems that the whole Earth has wobbled. There seems to be a connection between the geographic poles and the magnetic poles. They seem to be at a fixed angle to each other. So the magnetic pole shifting would shift the geographic poles as well. So this is possibly why we're seeing the Earth wobbling, and a lot of what is happening is this wobble would cause also a disruption of currents, of wind currents, and even charged particle currents that are in the Earth's atmosphere, on the surface of the Earth and inside of the Earth. Because of the increased induced magnetic field, you would get increased induced currents, which would disrupt all sorts of things inside the Earth and on the surface of the Earth and in the atmosphere.
Well, we're definitely seeing wild weather around the world. There's no doubt about that. It just seems now that every single minute of the day, there is a report about some crazy weather. Excuse me. The other day, I was witnessing a video in Turkey where they were getting pounded in Istanbul with these baseball-size hailstones, and it looked like a meteor shower. I mean, if you would have been out there in the street or uncovered, you would have gotten seriously injured, if not killed. These baseball-sized hailstones were coming down non-stop. Now, in the neck of the woods where I live, we just went through some flooding a couple of days ago, and now the water's receding. And it just came out of nowhere. They were calling for flash flood warnings 24 hours in advance because they knew what was coming. And we normally don't get weather like that. But all of the rivers swelled, and there is probably several hundred miles of this river leading into the downtown city area of the city of Pittsburgh. We're seeing this all over the world. I mean, we're seeing very extreme situations. And again, folks, like I've said before, this was not going to be just a one-day event. I knew deep in my heart that things were going to progress and progress slowly. And I mentioned it so many times back in the winter time. And I kept telling people, well, you just wait till we get into the springtime in the Northern Hemisphere. You're going to see things weather related that you've never even dreamed of. And in my 49 years on this planet, I've never seen anything like what we're seeing now with this extreme weather. But anyways, Doc, getting back to your report, and I mean, I know we were about to talk about these plasma connections that these stellar objects will make with the sun.
Yes. And here we have, this is one of the pictures from Germany. And as you can see, it's the same object. We see the same blue surface, the same grooves on the surface, but we can also see that there's less material attached to the surface of the object. This means that between May 12th and July 26, when these images seem to have been taken, that the object has lost quite a lot of the material that it had on its surface. You can see there's quite a change. There's still some material attached to it, but we no longer see the stripes. We see a lot less material attached to this object.
Yeah, there's absolutely no doubt about that. It looks like it's been stripped.
Then what we see is it looks kind of pinkish. It looks that's actually the sun's corona there, and I indicated with the blue arrow. And we can see that some of the sun's corona, the plasma from the corona, is actually almost attaching to the object. We
Yeah,
actually
I
see
could see that.
a more dense strip indicated by the blue arrow, where there seems to actually be a connection. It's dense enough that we can see the difference. So it looks like that part of the sun's corona is going out and attaching to this object. And then on the left side and underneath the object, we see a yellowish haze. And I think that's coming from the object itself. So what this is evidence of a particle flux transfer between this object and the sun. It seems that it's drawing plasma from the sun towards itself. There's even a connection, like we've seen with the 2012 object that was in the sun's corona, and it had a sort of umbilical cord towards the sun, but it was much smaller than this object. But this object is doing the same thing. We can definitely see it's like an umbilical cord between this object and the sun. It doesn't go all the way to the surface, but it goes halfway between the object and what seems to be the surface of the sun. And then on the other side, it's yellowish, also kind of gaseous on the left-hand side. And so that would mean that this object is also ionizing and producing some of its own plasma, and that plasma is being drawn towards the sun. So this is evidence of a particle flux transfer between this object and the sun. And that would mean that there is a magnetic connection between them, because these ionized particles are charged and they spiral along magnetic field lines. So that would mean that they are connected to each other magnetically.
Interesting. Yeah,
So
you can definitely see the connection. I'm going to try.
Yes.
I'm going to try to clear that photograph up a little bit more, but you can definitely see they're kind of like almost like rope-like structures, like an umbilical cord.
Yes.
You could barely see it, but there seems to be two of them.
Yes. That's right. I think it's probably more than one, because this is a large object. But you can see at the bottom, the object is not, you don't see the round surface. It's kind of a little bit of the pink gaseous or plasma seems to be jutting out from the surface of the object. It's a little bit triangular there. So that seems to suggest to me that there is plasma from the sun adhering now to this object. And further down, we see in figure 7, again, we see the surface of the object. We see the material that's clinging to it, the yellowish material. And on the bottom, we see what looks to be a gaseous haze above the surface of the object. Again, it looks to me, in this kind of environment, a gaseous haze is, of course, plasma, diffuse plasma like what we have in the sun's corona.
I'm going to go ahead and blow this up for everybody. So, you know, it might pixelize a little bit, folks,
Yes.
but what I want you to see is the surface of this monster.
Yes.
It's just absolutely incredible, and I'm hoping to get more images and hopefully get them cleared up a little bit, so you know they're ready for video presentations, so we could get a much higher definition on what we're actually seeing. And I mean, it's pretty amazing. You know, I'm almost once again at a loss for words at what we're seeing. But you know, I mean, this is what I eventually expected, was to hopefully one day, you know, find what we're looking for and be able to explain it to everyone.
Yes.
And disclose it. But this next photograph, this was much higher definition, and
Yes.
you can actually see some of these plasma connections. Now I can see a couple of them.
Yes, you can definitely see it much clearer in this image. I just wanted to show the first one where it wasn't as clear, but we could already see the connections, the plasma connections that are happening between this object and the sun. We can also, especially in this one, clearly see that it's a solid surface. We can see the grooves on the surface. We can see the what seems to be spongy material, which is obviously less dense than the stellar core itself, clinging to it. And this is an amazing picture. This is evidence. You know, when I saw your pictures of this large blue object, I thought this is amazing evidence, because I always thought that these objects were close to the sun and were causing some of the effects that I had observed happening with the sun, such as it going dark and it moving out of place and so on. But now this is absolutely the pinnacle of what I have seen so far, because it's so clear. And plus, we can compare what this object was like a few months ago and what it looks like now, and we can see that it has changed, and we can see how much it has changed, how much of that surface material it has lost. And on top of it, we can actually see that it is connecting magnetically to the sun. It's absorbing the sun's plasma. This is actually unbelievable.
So
Well, it is.
this is almost like the sun doing battle with
Yes.
this object. You know, they're trading blows.
Hmm.
The sun with all of the coronal holes and the
Yes.
flaring and these coronal mass ejections, and this object losing large portions of its surface, which we may be seeing as massive amounts of space debris.
That's right. Yes, these objects are definitely, when they come into the solar system, stellar cores are basically, they will have a gaseous envelope, and then they will have a debris field further out and more diffuse. And that that material would fill the solar system. And because we now seem to have so many of these objects, this is exactly what would happen. And don't forget, these objects have probably been coming into the solar system for over 30 years, maybe even 100 years. They're not visible initially because they emit only infrared radiation. But in the solar system, like this object is doing and close to the sun, they absorb plasma from the sun, and then they gather energy from the sun, and they start being able to do things that they were once able to do. So I call that rejuvenation. They never get as many layers of gas, I don't think, as they had as a main sequence star. But even a thin layer, which is they are able to ionize, may cause these objects to once again do things that main sequence stars do. In other words, they would have the churning, glowing plasma on the surface, even though it may be a thin layer, and they will produce light. They may even start producing fusion reactions, and therefore produce even a stellar wind like normal main sequence stars do. Except they would be a lot smaller, but because they only have a thin layer of this plasma on top of their solid cores.
Well, it definitely answers my questions for many, many years, why they're chemtrailing the living hell out of the skies around the world every single day. You know, years ago, folks, I mean, I used to report on these chemtrails. I mean, the chemtrailing pissed me off so bad that, I wish there was something that I was able to do about it. You know, they're just spraying us with poison each and every day. And now you can actually see and realize and understand the reason why. You know, it's pretty messed up what they're doing. We don't have any control over it.
Yeah.
But I think the more and more we publicize it, the more and more eyes that open, and the more people that open their ears and listen will understand that this is, like the doctor has said before, this is the biggest cover up in world history, bar none.
That's
This
right.
this takes the cake. I'm going to go ahead and zoom into this object here, so everybody can take a real good close look at it there. Oops, I went a little too far. It's definitely an unusual looking object. The
Oh, yes.
surface looks like it's been strifed
Yes.
with something, and there does seem to be some smoothing of the surface here and there, but it's definitely very, very odd looking. You
Mm-hmm.
know, I mean, we're all so used to looking at our planets, Saturn and Jupiter and Mars and Venus. So I guess we kind of get desensitized to what really, really might be out there because, I mean, let's just face it, folks, we haven't seen but a tiny, 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 tiny little fraction of what is actually out there,
Yes.
in our galaxies and in our universe. It's amazing. Now,
Mm-hmm.
this photograph here that came in, I mean, this actually looks like another spherical object right below here.
Yeah, that's right, Scott. So this is the large blue object and the sun. Again, we can clearly see the plasma connection between the two. It's like the sun's corona has gone out to envelop this object. And you see that the object is not affected except that it's losing its own material. And I think what is happening, the way it's losing it, is it's managing to ionize some of this material that's clinging to its surface. So it's turning into a plasma and it's exchanging it with the sun. So it's going out from its surface, going towards the sun, whilst it's absorbing some of the sun's plasma. And what might happen is eventually it will absorb enough plasma from the sun for it to completely envelop this object. Don't forget, the way we see object is every single object we know, except maybe for objects like the moon, where we can actually see its surface because it has such a thin atmosphere. Um, all planets we know of have atmospheres. So we don't see the core of planets. We don't even see the surface of planets as such. What we actually see is the atmosphere surrounding planets. And stars have the same thing. They have a huge number of gas, which is basically an atmosphere around it. Gas giant planets have a huge amount of layers of gas surrounding their cores. And stars and planets, we are used to always having this gaseous atmosphere around it. Of course, stars are able to ionize it to the point that it becomes churning hot plasma, which emits light. What we are seeing here, that this is why I call these stellar cores, is a naked star. It's a star without its layers of gas, which is it has lost in the course of its evolution. And but so it's a stellar core. It's naked, and we are seeing its surface, the core of a star.